Okay, it's the top of the hour, and I want to welcome you to the NCAT From Research to Implementation webinar series. This is our monthly webinar series that we do. Got an exciting topic this week, which is practical considerations for balanced mix design benchmarking. So balanced mix design is such a hot topic all across the country right now, but this benchmarking and figuring out where we stand with the mixes that we have, where should we set the limits if we're an agency, where do our mixes live if we're a contractor, where, what do we need to do to those mixes from where we have been to where we're going. They're all really important things that we need to figure out. So today we are joined by two NCAT staff, but we're parlaying off of somebody's experience with the DOT. So first of all, we've got Adam Taylor. He is a research engineer here at NCAT. He started as an undergraduate co-op student here in 2003, and he started his career as an engineer with NCAT in 2008. He specializes in mix design performance testing of HMA materials, and then he's involved in multiple NCAT projects. Many of those are related with balanced mix design. He is our go-to guy for performance testing. If you've got performance testing questions, he's your guy. He got both his bachelor's and master's degree here at Auburn University, and he's licensed in the state of Alabama. Next, we've got Zane Hardzog. He got his civil engineering degree here at Auburn University in 2012. And then after working for the Alabama Department of Transportation for 10 years, being the bituminous engineer for ALDOT, he came over and joined the NCAT team here just a few months ago, about three and a half months ago, that we got him over here. Zane's main research interests are in balanced mix design, implementation of research, asphalt quality control, and quality assurance. He is also licensed in Alabama. And so that's our two presenters today. I do want to remind you, please stay muted. As we go through this, please put any questions that you may have in the chat box so that we can address them at the end. Kind of our content for today, we've had our little bit of an intro. We're going to turn it over to Adam to give us our laboratory considerations. Zane's going to give us agency considerations. I'm going to share BMD resources with you. We'll go through our questions, close it out, and try to be out of here within an hour. So, given that, Adam, you ready to roll?
All right. Well, good morning, everybody. So today I'm going to talk a little bit about, we call this practical considerations for BMD benchmarking. So we are going to talk, just a little bit about how do you make benchmarking work, especially from my perspective, in the laboratory. How do you collect meaningful data that you can use to make informed decisions? So thinking about the definition of balanced mix design, it's asphalt mix design using performance tests, which is what we're interested in, on appropriately conditioned specimens that address multiple modes of distress. We take into consideration aging, traffic, climate, and location within the pavement structure. So for benchmarking, we're concerned with using performance tests. We're concerned with having performance tests that address multiple modes of distress. And we have to take into consideration, things like aging in order to, determine the value of the results from those tests. So let me see here. With respect to benchmarking, we have to be able to select a test for different modes of distress. In this case, typically that's going to be a test for rutting and a test for cracking. The definition of benchmarking is to evaluate or check something in comparison with a standard. So the two big questions we have is, with respect to benchmarking, is if you're, an agency or an organization, how do my mixes currently perform? And then how do I want them to perform? Benchmarking is figuring out how do I figure out how my mixes currently perform. And we're going to dive a little deeper into that. So just kind of overlooking benchmarking in general, and I think Zane's going to give a lot more valuable information on this front, is you have to select a laboratory test for each distress. You have to procure equipment and train people on how to use it. you have to get material to test. So you have to think about what materials you're going to get in order to test them. You have to figure out how to make specimens with that material and then how to age those specimens. With the specimens you're making, you have to ensure that they're of good quality and you have to have enough of them to make meaningful conclusions. And at the end, you look at all this and say, do my results make any sense? So you're going to have a large, eventually, you're going to have a large body of data and you're going to have to make decisions off that body of data. I figure in the audience, there are people that are at various stages in this process, from haven't started yet to, kind of just beginning this process to have already benchmarked half their state. So I'm just trying to keep that general. Some feedback that I've gotten in the past, from different agencies, like when they're just getting started out, is, okay, I'm collecting these data, I'm getting test results, they're kind of all over the place. What does it mean? So that's kind of what I want to get into a little bit here. So how do my mixes currently perform? In order to do that, we have to collect materials. We have to collect representative material from multiple paving jobs, preferably with a range of field performance, mixtures with a good performance history, mixtures with a poor performance history. You have to think about what types of material you're going to collect, whether they be current projects or historical projects. The pros and cons here, if you have mixed designs for in-place pavements or pavements that have been in place for a few years and you have some performance record of them, that's great. But do you still have materials that you could work with in the laboratory to quantify how those mixtures performed in the lab? And most times that's not the case unless you were thinking ahead a few years back. There's a couple of different ways this material could be tested or benchmarked in the laboratory. You have LMLC, laboratory mixed laboratory compacted specimens, and you have PMLC, plant mixed laboratory compacted specimens. So if you're dealing with raw materials or lab compacted specimens, this is going to represent what that material would have looked like during design. So you're doing a balanced mix design, you're performing a running test, you're performing a cracking test, you're going to get results that would have mimicked the design of the results you would have gotten during design. One caveat here is that with respect to raw materials, your binder source really matters. So if you're going to have a project and you're going to benchmark it, that's going to need to be benchmarked with the exact same binder that would have been used during production later on. With respect to plant mix, this is going to quantify how that mix actually performs during production. This is going to be more representative of what actually goes out onto the roadway. One thing to consider with plant mix is where the material is tested. We typically have a couple of aging conditions for plant mix. We consider what we call hot compacted or production specimens. These are specimens that are produced and typically tested on the same day the mix is paved. So the mix is not allowed to cool down, it's not reheated. So hot compacted is not reheated specimens. Reheated specimens are the material is sampled in a container, typically a bucket or a box. It's allowed to cool down and then it's reheated at a later date, split, quartered, and specimens are made out of those. I say all this because typically you're going to see some slight differences in material that is hot compacted versus material that's reheated. Generally, the hot compacted specimens are going to be slightly softer. Reheated specimens are going to be slightly stiffer because they've had more time in the oven. So as you're benchmarking, this is something you want to be cognizant of and consistent with how these specimens are being tested. Are they hot compacted? Are they reheated? So as part of the BMD definition, mix aging is mentioned. So this is something we also have to consider when we're collecting test results to benchmark our mixes. We typically separate it into short-term aged and long-term aged. Rutting is typically a short-term distress. In most cases, we are just going to do short-term oven aging on specimens for either wheel tracking tests or for some of the rapid rutting tests, such as the high temperature IDT. Cracking is typically an intermediate to long-term distress. What we've seen, particularly here at our test track, is that as pavements oxidize, as they kind of get in that 3 to 5 year window, they become a lot more susceptible to age-related cracking. So, in an ideal world, we want to have some sort of long-term oven aging or conditioning on specimens for laboratory cracking testing. In the real world, that can take a long time, and we're trying to turn these results around quickly, especially if the test is going to be used for production. So that's something that has to be considered as you're benchmarking results. Are we collecting short-term age cracking test results, or are we conducting some sort of long-term aging on these results as well? During design, you can kind of do whatever you want. You have the latitude to, you have the benefit of time. So long-term aging is more appropriate. But if you're testing plant-produced materials or you're trying to test same-day plant-produced materials, you're limited in what you can do. You have to have a faster turnaround time. Just calling your attention to current aging standards. These actually just got released a week or two ago. I think they're relatively current. There's 2024 editions of the AASHTO standards. AASHTO R30 has been modified to 2024. That is short-term laboratory conditioning of asphalt mixtures. This is typically going to be 2-hour aged at 275F, though there is a note in there that temperature can be increased for mixtures with, I believe, with modifiers or for warm mix asphalt. And then AASHTO R121 is a new standard this year for long-term laboratory conditioning of asphalt mixtures. I believe there are 5 methods in that spec. I think ranging from compacted specimens to loose mix aging. So there's multiple options available within that standard. The option that was kind of developed here and that we use on a regular basis for most of our research is NCAT critical aging. That's going to be method E in the R121 spec. That is going to be loose mix aging at 135C. So you see here a sheet pan off to the right. So we'll typically take about 2,500 grams of mix, spread it across a pan of these dimensions. That's your typical restaurant half sheet pan. And it's going to be long-term oven aged or conditioned for either 6 or 8 hours at 135C prior to being compacted into specimens for performance testing. So something to consider as you're benchmarking mixes. You have to define an aging condition both in design and then in production, and you have to connect the dots between the two. With respect to lab equipment, again, you have to procure equipment. It's important to maintain calibration on these machines, particularly things like, say, for presses that would be used for the IDLCT or for the high temp IDT. You have to calibrate load, you have to calibrate displacement. Things such as the Hamburg, you're going to calibrate wheel passes, you're going to calibrate water temperature. You have to have trained operators, both to run the equipment and to make the specimens. And I say that because for most of these tests, making specimens is more important than running the equipment in terms of the variability you're going to see in the test. A lot of these tests are relatively easy to do, but a lot of your variability is going to come from poor specimen prep practices. In this space, I gave a webinar on that about a year or so ago. So I won't reiterate too much of that here, but I think it's important to stress. So with regard to testing, one thing I wanted to point out was the value of temperature. Small differences in temperature can have a huge impact on the stiffness of your asphalt specimens, particularly things like the IDLCT. You're conditioning either in an environmental chamber or a water bath. You have to know what the temperature of that conditioning medium is, and it has to be accurate. Doesn't have to be expensive. It just has to be an accurate conditioning medium. One thing we do here, we keep one thermometer me see if I, within our lab that we call a referee thermometer. This is a thermometer that's not used for testing. So we send this off for calibration every year. It stays locked up in a cabinet. It's not used for day-to-day testing. What it is used for is to verify a lot of our other day-to-day probe thermometers that are used for other things throughout the lab. So for example, here over on the right, I've got one of our kind of our handheld testing thermometers with just a thermocouple coming out of it. And I've got it stuck in a water bath here. You see down at the bottom, I've got a sticker where 24.8 equals 25. So 25 was the temperature in the referee thermometer. 24.8 is what this little handheld is going to read for that true value. So we keep this is a good practice to have for in-house verification so that you can check the temperatures of the thermometers that you're using day to day. So replication and variability. So again, I've kind of gotten feedback from people that are just starting the benchmarking process regarding like consistency of their data. Like, hey, my data is not as consistent as I would like it to be. What can I do to improve it? So place to start with any test is whether or not that test has a published precision and bias statement. So AASHTO T93 is for the iFit. That actually has a pretty good precision and bias statement. It lists the within lab and the between lab expected coefficients of variation for the test. A lot of tests, particularly in this space, don't have a fleshed out precision and bias statement. They'll have a limited one and then say the full precision and bias statement is anticipated to be published by X date. There is other information out there on the variability of these tests. I mentioned kind of some of the work we've done here related to the NCAT round robin, where we've looked at variability estimates for wheel tracking tests, for rapid rutting tests, and then for the ideal CT. We've done one of these studies each in 2019 and 2022, and we're about to start our next one here late this year, early next year. And the report for the 2019 study is published as NCAT Report 22-01, and the report for the 2022 study is pending publication. So with respect to replication, common topic is how many replicates should I run? One thing I want to stress is that more variation means you need more replication with respect to a test. I think as asphalt engineers, for a lot of folks, the default setting is 3 replicates. In performance testing, 3 replicates isn't always the answer. Sometimes you need to run more than that in order to get good, repeatable data for what you want. I'll give an example here of the ideal CT versus the high temperature IDT. So the ideal CT is a cracking test. The high temperature IDT is a rapid rutting test. Down below is some of the precision or variability estimates that we've conducted from a couple of these studies. For the ideal CT, we know the within lab coefficient of variation is 18 to 20%-ish. For the high temp IDT, we know it's in the 5 to 10% range. It's a much more repeatable test because all it's getting is a peak load, whereas the ideal CT is collecting 3 parameters from a full load displacement curve, and they're more variable. Within our lab, we're typically going to test 5 replicates for CT, 6 if I have my preference and I have enough material. 3 for high temp IDT is sufficient because the CT index is a more variable parameter than the indirect tension strength from the high temp IDT. So one note I'll make here is that, if you look in the specs, there's always a minimum number of tests to run. I looked at the ideal CT spec, I looked at the iFit spec, and they say minimum of 3 replicates. One thing I'll stress, that is a minimum. It's not necessarily what's recommended that you should do. So typically for ideal CT, we're going to run 5 or 6. For iFit, we're going to run 5 or 6. For some tests, 3 is fine. For a lot of other tests, you need to run more. So I don't know who said this quote, but I like it. It's the cheapest way to do something is to do it once and do it right. This is something I try to impress on a lot of my students as they come through here. One thing I try to stress is to avoid pulling sets of specimens together from multiple production runs. So if you're trying to get a set of iFits or a set of Hamburgs, let's just say you need a set of Hamburgs, so you got to make 4 specimens. So you make 4 specimens, 1 or 2 of them miss air voids. You go, well, crap. Let's make a couple more. One of them misses air voids. Well, crap. Let's make another one. Okay. So now you're splicing a set together from material that's been compacted on different days, different oven conditions, potentially different operators. All of that's just going to increase your variability. What we typically do here is just make more the first time. And if you throw some away, you throw some away. If you have extra, great. That means you did it right. If you need 4 specimens, I would just go ahead and make 6. And if I need 1 bucket for something, I'm going to go ahead and sample 2. I would much rather have extra material at the end than have to go back and remake things, because every time you're having to start over, you're putting together specimens that were made under different conditions. It's a cheap insurance policy, essentially. It's a good way to ensure that you do something once, you're going to get a repeatable, good data set from that material. One thing I've heard feedback from a few different labs is getting inconsistent air voids. If air voids are consistently inconsistent, that may be a symptom of something else going on with respect to laboratory specimen fabrication practices. Again, I gave kind of a whole thing on this last year, but I'll talk a little bit about some of the tools that are available to you. But getting consistent air voids is usually shows that you're having some repeatable laboratory practices. I mentioned coarse versus fine mixes. As generally as the mix gets coarser, it becomes a lot more important that you have good quartering practices, you have good sampling practices, because the potential for segregation is much higher. As you go from a 9.5, as you go to a 12, from a 9.5 to a 12.5 up to a 19, the potential for segregation increases. As you go from a fine graded mix to a coarse graded mix, the potential for segregation increases. If you're dealing with lab mix, this is where fractionation is extremely important. Especially fractionating aggregate on all the sieve sizes down through the number 8 sieve. If you're dealing with plant mix, it's being able to use tools like a quartermaster or a splitter, or just essentially following ASH to R47 to get good representative specimens. Okay, some tools that are available to help. I'll go ahead and wrap this up. We recently published a guide on the Napa BMD Resource Guide. It's a specimen preparation guide for BMD materials. It covers all things related to plant mix specimen fabrication and lab mix specimen fabrication. We also have a tool, I'll plug this as well. It's a trial mix weight estimating spreadsheet. The QR code down here will lead you to that. What that does is it's going to give you a good starting estimate of the amount of mix that has to go into the mold in order to achieve a target air voids. And again, if you're getting consistent air voids, that goes a long way towards getting consistent results in the laboratory. The sheet is there. It's free for download. There's an instructional video to help you out as well. Again, we have kind of the NCAT round robin that's ongoing. We're about to start up our next round robin study with a new mix after we get done with test track construction. I'm not sure if there are additional spots available in there, but if anybody's interested, I can check on that. It hasn't started yet, and then we're hoping to send mix out again either at the end of this year or at the beginning of next year. And the last thing I'll mention too is like laboratory accreditation. Just being an AASHTO resource or equivalent accredited lab is going to go a long way towards getting repeatable results. I noticed, back in our shipping room that AASHTO is actually starting to do a Hamburg proficiency sample. So that's something that they have just started. And I anticipate they're likely going to get into more proficiency testing for different tests as time goes along. So with that, that's all I have for the moment, and I'll turn it over to Zane and let him talk about benchmarking from the agency perspective.
So benchmarking. Adam talked a lot about the lab side. I'm going to talk about things you could consider as an agency and, how to handle all the data, how to use the data to make decisions, hopefully, how to gather accurate data and enough data. So benchmarking. This is what an AI image generator thinks benchmarking is. If you have vandal squirrels, I would encourage you to contact pest control and/or local law enforcement. But that's not what we're talking about. We're talking about performance testing a representative set of currently approved asphalt mixtures, probably using multiple performance tests, and your location will probably dictate what kinds of tests you want to use. But what does representative mean for your agency or your state is a question we'll talk about a little bit, and what tests are important to. Okay, so it's always good to start with why. Why are you interested in benchmarking your mixes? Is it because it's an early step to implementation? Is it so that your technicians can gain some experience with the different tests? Maybe it's even to determine which test to use. Is it to understand the variability of your mixes and the variability of the tests? That's something that's very important to agencies and contractors. We're used to volumetric tests that have repeatability measured in hundredths or thousandths, and going to something that has a coefficient of variation of 10, 15, 20% can be a little daunting. And a lot of people phrase it like this: we're benchmarking just to see where we are, to see what our current mixes do on performance tests. So is there a specific problem in your state, municipality, county, whatever, that you're trying to address? Do you have a lot of fatigue cracking? Do you have dry mixes? Is rutting a problem? Maybe a stripping is still a problem for some agencies. Is thermal cracking the problem? So I'm in North Dakota this week for their balanced mix design validation project, and thermal cracking is kind of the problem. They care about other things, rutting and fatigue cracking, of course, but it gets real cold up here. I'm told -20 is not uncommon, and wind chills into the -40 range are a pretty regular thing every winter. It's just not something we deal with in the South, but for them, it's probably their biggest consideration. So given that each area of the country has its own conditions, it may be a good idea to make some local adaptations to your mix design, or not to your mix design, of course, to your mix design, but also to your performance tests. So in Alabama, when I worked for the state of Alabama, we altered the ideal CT test into ALDOT 459, the Alabama cracking test, which is nearly identical to the ASTM procedure for the ideal CT test, with the exception that it specifically allows screw drive presses, because those screw drive presses were in every lab. Generally, the state has one in every asphalt lab, and the contractor has one in every asphalt lab. They're just everywhere. So that alleviated a concern that a lot of our areas within the agency had about equipment costs, and that our contractors had about equipment costs. And one of the more common methods to adapt to specification is to just change the temperature. So in Alabama, we typically do 50C conditioning for our rutting tests. Here in North Dakota this week, I'm conditioning all our rutting test samples at 46C. And that one makes perfect sense. And a lot of those rutting test specifications don't even give a temperature. They just say adapt the temperature or follow the agency standard for temperature. You could also use more than one. You're early. If you're benchmarking, you're pretty early in your implementation. You could use more than one test for similar properties. It's a pretty good idea to use one monotonic test. So that means one load applied, like an ideal CT. We're just going to break the sample, and a cyclic loading test for the same property, just to see how they differ. So a cyclic loading test would be like the Texas overlay, where it pulls on the sample over and over. And on the rutting side, if you're not sure if you'd like to use HT IDT or ideal RT, run both on some mixes. See which one you have, get better data from, see which one's more representative. And then you could also add a cyclic test like the Hamburg or the APA and compare your results with that. See which is correlating better for your mixes. You can also think about aging conditions. So in mix design, Adam mentioned a couple different AASHTO standards there that have different aging conditions that you can use. And there's aging and conditioning, right? And we call the short term their conditioning, and generally the long term we refer to as aging. But for plant mixes, maybe you don't age them or condition them at all. Maybe you just get a bucket of it and compact it, keep it hot. And that's most representative of what goes down on the road that day. So for a rutting test, that unaged condition of plant mixed laboratory compacted is probably your worst case scenario. It might not be the case every single time, but it probably is. The mix is most plastic in that condition. For a cracking test, it's going to be long-term aging typically. That's the worst case scenario. So you need to think about that and record the data such that the aging condition is associated with the test result, because it can become quite confusing if you don't do that. You won't even be comparing apples to apples. You'll be comparing apples to a stegosaurus at that point. So document those aging conditions. So the data, you're going to generate a lot of data when you're benchmarking. And you need to think about who is going to be responsible for keeping track of all that data. If your technicians in the lab are going to enter all the test results and mix properties, it's going to take up a lot of their time. And anytime you have data, you really need to run QC and QA on the data. Somebody needs to be spot checking it, because just the amount of things that have to be entered into a computer, the odds of a small mistake being made somewhere are just, the stats will catch up with you. You need to think about what you're going to record for each mix design. Obviously, you want to record the data for the test result, but you probably want to record the replicate data. So if you run 5 ideal CT samples, you probably want to record each data point and not the average, because that's going to let you calculate things like your variability and your standard deviation, coefficient of variation later for the test. And that's going to be essential information when you're trying to use this to make decisions. Who will have access to the data? So if the database is a spreadsheet on your laptop, nobody will have access to your data. So you may want to consider something, at least a shared spreadsheet. If possible, if you have a materials database that has online access that you're already using to store mix design information, can you integrate this test data into that, so that when someone pulls up a mix design that's part of your benchmarking study, there's something in oftentimes these databases have a notes section, and you can just manually enter in the data in the notes section. It's not the most efficient when you need to retrieve it later, but it's better than nothing if you want a lot of people to have access to the data and to understand what's going on. Something to consider there is if you're recording replicant data, you also need to record the aging condition for that test. If you run more than one aging condition, so if you run tests on more than one aging condition, you need to be able to store the data for each aging condition separately. So using Excel for this one, I love Excel as much as everybody else does, but it gets out of hand. It gets out of hand pretty quick if you're trying to store all that in Excel. So something to think about. How are you going to store the data in such a way that you can actually filter through it and make decisions later? Some things that you want to consider keeping in that same database with your test replicate data. The mixed design data. So the AC percentage, the grade of AC. You may even want to keep the source because sources do affect mechanical test results. Any additives, so if it's a polymer modified, Hamburg, for instance, you can really improve a Hamburg result on an aggregate that has a little stripping by adding antistrip. So you may want to put in that, this mix has anti-strip and which anti-strip it has. I've got a geologic map of the state of Kansas over here because I had this big empty rectangular spot and I was like, what state will fit in this for a geologic map? So I don't know a lot about the geology of Kansas, but I would bet that the aggregates in this purple section over here on the right are not the same as the aggregates in the green section in the north central area of the state, and they're not the same as the aggregates in the yellow section in the bottom left corner here. So it's good to record geographic data, especially if you know that your aggregates affect how your mixes are designed. And you know that, for instance, if you have an absorbent aggregate in one area, it's going to be good to record that this mix design came from this area. And you may have to turn the AC up a little more than you do in another area to get good performance results. And if you have an area with aggregates that are prone to stripping, then you need to add antistrip for those areas. And when you see that stripping inflection point creeping closer and closer to the beginning of the test in a Hamburg, for instance, you can associate that up. That's that area of the state. We know what's going on there. Let's add antistrip and let's run that Hamburg again and let's see what it does. Other considerations you may want to make as an agency. You're going to need people to run these tests, and they are time consuming to prepare samples for, and some of them can be time consuming to run, like a Hamburg that takes half a day to run. You may want to consider putting that machine in a location where you can run it all day and the noise doesn't annoy anyone, and maybe you can run it at night too. So Hamburgs typically have a water bath. It's good if you can put that somewhere where something goes wrong and the water bath overflows, it's going to be okay. There's a floor drain or there's a drain to outside so that you can run those specimens all night. For personnel, not only is time a consideration, they need to be trained in specimen preparation. A lot of these tests require saw cutting specimens. It's fairly tedious. You have to make a lot more specimens than you think you'll need, especially early as your personnel are learning. And I know somebody that would like nothing more than to help you train your personnel. So, and he's on this call, so we can talk about that a little later. Pavement management data. Can you associate? Is it possible for you to associate your mixed design benchmarking data with non-pavement management data? It may not be possible for everybody to do that. You may not have thorough enough data on what mixed design went where to do it, but if you can, it's quite a good learning tool. And I know there are at least a couple states that have done this. They know what mixed design is where on the road. They have pavement management data for cracking, rutting, and ride quality in those sections. And so they were able to go back and, as best they could, recreate those mixes with the same aggregates from the same quarries and similar liquid source, but of course you can't get the same day's liquid from a mix that's been on the road 7 years ago. And then they could say, this section has X amount of cracking and it got Y ideal CT score. And they have a lot of data on that, and they can use that to make effective decisions. Some of the equipment for balanced mix design can be quite expensive. The last time I looked, a Hamburg machine was, I don't know, $65,000 or so for some of them. So it may take time. Like you may have to, maybe you can't run Hamburg this year. Maybe you have to wait for the next budget year and budget for that equipment. That's okay. You probably have a screw drive press, and you can probably start running HT/IDT now, and that's going to build those personnel skills, because the sample preparation, the mixing and compacting in the lab is similar or the same for those. The only difference is a saw cut for the Hamburg, right? So start with what you have is what I'll say. If you have a screw drive press with a digital readout, or you can get a digital readout for your screw drive press, or you can even use the paper, the screw drive presses that output the paper report, especially for something like HT/IDT that only uses the peak load. Adam talked a lot more about aging conditions, but I'll touch on it just a little bit. So there's a lot of different ways to go about this, but if you can get all of the aging conditions, a lab mixed, lab compacted, so what we typically think of as like a mixed design specimen, right? And then a plant mixed, lab compacted with or without aging, and then a plant mixed reheated specimen, right? And we can see how the data changes for the different tests from one aging condition and one mixing condition to another. That could be valuable later when you're trying to go from mixed design to QC and QA. So eventually, if you want to use some balanced mixed design tests to approve mixes that are as they're being used in the field, production mix, it would be very handy to know how they typically move through that mixed design phase to an aged condition to a plant mixed condition. And then if you have to referee test, it would be very handy to know what it's like in a reheated condition. Typically, just the more aging you have, you lose some cracking performance. And typically, the less aging you have, your rutting performance will be a little worse because the mix is not as stiff. That's not 100% factually always the case, but that's just typical. Benchmarking some of your mixes may be a good off-season project. If you're coming to the end of your paving season, starting to get cold where you are, then this may be something that you can do when your personnel have a little less work in the lab. It's another good thing to think about. So with when I worked for the state of Alabama and we did a benchmarking study, we had contractors, as they submitted mixed designs for approval, we had them go ahead and submit enough samples that we could run an HT/IDT and a Hamburg with their mixed design. And the contractor prepared those samples in their lab because we didn't have the personnel to prepare those samples and keep our mixed design approval throughput where it needed to be. So that's something you can think about. And this is just a screenshot of some samples over here this is from the Alabama Balanced Mixed Design Validation Study. Some very good air void repeatability on those, and that comes with lots of practice. So as you're moving to implementation, some things you can think about are, you might want to develop an interim threshold. So you can look at mean, median data for a particular test or a certain percentile of your data. Let's say you have a great big average of all ideal CT tests for a year of approved mixed designs in your state. If you have a reasonable mean on that, and we'll look at a graph of some data that I have later, and and you tell everybody that this is the interim threshold. All mixed designs must have an ideal CT index equal to or greater than the mean. Okay, you just drug the bottom half of your mixes up. That's a huge improvement. I mean, it sounds, you can phrase it in a way that it doesn't sound great. Oh, all our mixes are at least average now. Well, no, that is great. That is great because your new average moved way up, right? So that may be enough to get you a lot more performance than you're getting now. You probably want to move into a validation study at some point, right? You want to go from benchmarking to shadow projects to validation. You can use this benchmarking data to determine reasonable values for your validation study. And that's what we did in the state of Alabama. We had this benchmarking data. We knew what was achievable in certain regions of the state, and we developed targets for our validation study based on that. You could also do what they're doing in North Dakota right now is more of a prescriptive specification for their validation study, where they're saying, okay, we've got one mix design, but we're going to put two different binders in it, 58-28H and a 58-28S. Okay. And then for those two binders, we're going to go down 0.5% on liquid from optimum, up 0.5% on liquid from optimum. We're going to produce the optimum, and we're going to add 15% wrap. That's fairly simple for the contractor. They don't actually have to design 8 different mixes, but now they have a validation study that has 8 different mixes, and they know from their benchmarking data that would give them a good spread for the validation study. For shadow projects, you can overlap this a little bit with your benchmarking. So when you do a shadow project, which is having someone at the plant testing mix as it's being produced, you are benchmarking that mix design for a plant mix lab compacted condition. And this is a good thing. There's no better experience for a technician than testing mix live like that. It can be quite challenging to make those 7% plus or minus a half air void samples in a live condition like that. So it's a very good experience. Here's a little example data that I have. Let's see if I have a laser pointer here. Here we go. So this is data from, I think there's about 240 mix designs represented here. Just a screenshot of a graph, but the mean of this data is around the mid 40s for both CT index on the vertical axis and HT IDT and PSI on horizontal. So the mean is right around here, right? So when we were designing targets for our validation study, we can kind of look at this and see what's attainable. There is no shortage of mixes with a CT index over 100, right? We can get that. Now, we may not be able to get a super high HT IDT number with that mix over 100. The maximum there looks like it's around 70. But that's quite high. We don't need that. We'd be happy to have a mix that's over 100 and has an HT IDT of say 40. Right? So you can make a graph like this, and if you have good filters you can put on your data, you may be even able to make that graph for a region of the state and a certain test and make some good informed decisions. Okay, and now we're to questions, and on the left there, that's my daughter, Colby, and on the right, that's my son, Titus. I always like to put them on my "Do you have any questions" slide. But I'm going to stop share.
Kind of wanted to tie things together here a little bit while I'm watching that chat box for some questions to come in. These guys both covered some really great points. I think, Adam really covered that we need to look at both lab mixed and plant mixed because there is that difference, right? What happens when we go to the plants, and are our numbers going to come out the same? I think he really focused on how the proper lab procedures are so important to follow when we're doing benchmarking, that if we're cutting corners, taking shortcuts and that type of thing as we're trying to really establish where we are with our mixes, whether that's from the agency side or the contractor side, we're doing ourselves a disservice. The sample preparation, we hammer that every time we talk about BMD. He did show you a shot of the publication that he was a part of drafting up and writing for Napa. That's a wonderful resource. Plus, there is YouTube video of that available as well. Those can both be found on the Napa BMD Resource Guide page. As we kind of moved on to the things that Zane talked about there, what distresses are we concerned with? The testing that needs to be done in the state of Washington is not necessarily the testing that needs to be done in Colorado, right? Or in Arizona. And so it's important to know which kind of distresses we're most concerned about there. I love the discussion that he had about the data management and sharing. I'm such a data share person anyway, but making sure that the right people have access to that information is important. Bringing stakeholders together, I think, is part of that sharing of the data. Personnel training and the skills, that kind of loops back up to Adam's discussion on making sure we're following our proper procedures there. And I like that discussion of start with what you have, right? Take the equipment that you have and get your technicians used to building these performance test specimens as you're trying to figure out where your different mixes come into the different tests. The implementation and validation is a very important steps as well when it comes to that, and it helps us find what that attainable threshold may be. Now, both gentlemen talked a bunch about aging condition. That is such a question that's out there. So whether you're an agency or a contractor, you guys need to kind of come together with that and figure out what's going to be required there, right? If the agency's got an idea where they want to go with aging condition, they need to make sure and communicate that with their other stakeholders so that they can figure out where to go. There's several different methods that are published with AASHTO that can be followed there, but certainly there's not a consensus nationwide, and really does make a difference in these tests. So that's important to know as you move into your benchmarking. I want to push a bunch of resources out to you all, give you some idea of some things that are out there. There is this NCHRP 10107 document that NCAT has published as our own report. At this point, it's a guide for implementation for balanced mix design specifications. And chapter 5, or step 5 in the 8-step process there, does cover benchmarking. So there's some great material if you get that. I'm going to give you guys some websites and share. I'm going to dump a bunch of websites into the chat box for you, but I'm also going to kind of go over which ones are really important from my perspective as we look at those. But you can find that on our website. There's also the Balanced Mix Design Resource Guide that is a document published by Napa, another great document full of helpful tips on how to move through this process. And I do like also that the Capri has published guidelines and recommendations for the field validation. And it kind of goes through how you move from the different steps in the pre-implementation into putting this to work, how to put together those projects that are out there. One of the fun pieces is that that photo that's on that document happens to be in the state where Zane's hanging out doing a validation project right now in North Dakota. I did push the links into your chat box. If you'll copy those, you can use those later. Some of the Balanced Mix Design resource websites that are out there, you can certainly hop into our NCAT page and see what we have there. Trying to get my laser pointer. Here's kind of a picture of what that is. There's a lot of resources as you scroll down through there. We primarily send people to Napa. There is a Balanced Mix Design resource page with them. I'm going to highlight that a little heavier here coming up next. Capri is definitely another site where you can go. They have a whole page dedicated to Balanced Mix Design. They'll push you to Napa as well, but there's additional information there. AIEI, not sure how many of you know what that is. I'm going to spend a little more time with what that is coming up here in a moment. And certainly the Federal Highway Administration, they have this tech brief that's out there. It's HIF 22-048, and it is those 8 steps for implementation. Again, step number 5 includes the benchmarking portion. So Napa's Balanced Mix Design Resource Guide, fantastic place to go find out all sorts of information, what approaches can be done, what can be done with the test, where different states across the nation are with implementation and beyond. I think there's some Canadian providences that are listed there. There's a tremendous amount of resources. This resource page is where you can go and find both the videos and the document on sample preparation. Under the tools page, you can find the spreadsheet that Adam talked about for finding the batch weight for the specimens. And while we were having that discussion, I know Amy popped up and mentioned something there. John Young in Hawaii said his contractor's been using it and they've really enjoyed it, found it very helpful. So feel free to go and grab that. And then there's some discussion on their working group. So how do you find this page? Let me tell you what, it is not the easiest one to find if you just go to NAPA's website and drill down. So my recommendation is always just to Google it. Google NAPA BMD Resource Guide, and that will dump you right into this page, give you great resources. So AIEI stands for Asphalt, Innovate, Enlighten, and Implement. And this is part of an FHWA co-op agreement with University of Nevada, Reno. There's a tremendous amount of BMD work that has been done here, kind of have been labeled this AIEI. If you want to connect with them, LinkedIn is a great way to do that. They're very active on LinkedIn. They do have a bunch of BMD stuff going on there. This is part of the second quarter's newsletter, and it talks about a bunch of the BMD peer exchanges that have been done around the country. You can go in and read the notes. They're about 30-page documents or so from each of those regions. So if your region has already had theirs, I think the Mid-Atlantic's the only one that's not been done yet. You could pop into this AIEI newsletter, which and kind of bounce from there. And that's one of the things that's in the links as well, is the publications from UNR. And that is in their rapid deployment of innovations for asphalt pavements, is what this AIEI kind of marries up with that exact same program. So those are a bunch of the resources that I feel like we have out there. I've not seen much for questions. Roll in. So given that, Adam, I was going to ask you really quick, as a contractor is going to move forward with their benchmarking and figuring out where their mixes are, what do you think is the top 3 priorities that they should focus on?
Getting a proper sample.
Right.
So whether that's with a bucket sampler or having a good sample stand set up, reducing that sample. I'm talking about plant mix here. So taking that sample and reducing it to testing size appropriately. That's where you'll follow AASHTO R47. So reading AASHTO R47 and some of the practices that we outline in that guide. So get a proper sample, splitting that that sample down so that it remains representative as it's split, and then testing enough replicates. So understanding your test, looking at your variation relative to published criteria, and if seeing it, whether or not you're in the ballpark of that.
Okay, that sounds good. Zane, from your perspective with an agency, what do you think are the 3 most important priorities they should look at as they're trying to balance, as they're trying to benchmark the mixes that they have throughout the agency?
So I'm going to say the biggest challenge is as opposed to a contractor where you have your mix designs for your plants, an agency probably has a lot more mix designs to look at, right? The biggest challenge is probably cataloging all that data in a way that you can use it to make decisions.
Okay.
Beyond that, I would say training your personnel so that they can fabricate samples effectively and fairly quickly, and that they're not going back to make more, because that uses up a lot of time. And as Adam said, you can't necessarily trust that samples fabricated on 2 different days, or especially by 2 different technicians, are the same. So I'm going to say, what are we going to do with all this data so that we can use it to make decisions? And are we well trained in fabricating specimens and running the tests?
Okay, great. I appreciate that. Thank you very much. Did get a question on if the recording will be available. It will. It takes a couple days for us to clean it up, and then it will be made available. I'm not going to just send it out. If you want it, please, by all means, reach out to me. We can go from there. All right, our emails are listed here. Adam's and Zane's emails are listed, as well as mine. If you have questions, feel free to reach out to us there. You can find anybody at NCAT by going to our website, which is ncat.us. Going under the staff tab there, you can find any of us, find our contact information. I also like to plug a couple things that we have going on. Our research is, you can get on our site and find all of this research. This last probably about 3 cycles of the NCAT test track report are going to have something to do with BMD listed there. And we have several sections on the 9th cycle, which is currently under construction. The training in your pocket, fantastic place to go and catch a few. There's some new ones that are on there that have found some pretty good interest. And so we're continuing to make those. If you've not been familiar with training in your pocket yet, bounce that code there, or just go to YouTube and search training in your pocket. A great way to give people a very high level. There's several BMD training in your pocket tests that are on there. And there's also some overviews of BMD on there as well. So feel free to jump onto that. And like Zane mentioned, if you've got any training needs, feel free to reach out to us. We offer all sorts of stuff. We have a BMD course that we offer here, and I believe it's full already for November. So if you have interest in that, feel free to look us up and email us. We can go from there. Given that, I want to make sure and invite everybody to the October offering of our From Research to Implementation webinar series. I've got a couple topics in mind here. I'm waiting on confirmation from presenters before I can give you guys that topic. But please watch whatever channels you have been to find out what that topic will be. I'm going to bounce that QR code over here in about 3 minutes so that it will show you the October date and give you the October links for that. Anytime you do see a QR code from this webinar series, that does take you to whatever the latest one is. So given that, Zane, I want to thank you for joining us from way up north in North Dakota. Adam, I want to thank you for joining us from the lab back here. Any final words from either one of you?
And just thank you for tuning in, and reach out to us if we can ever help you with benchmarking or anything else.
There you go. Sounds good.
Yep, same. Thank you.
Okay, sounds good. Thanks, everyone. We'll see you next month.